Today we're starting chapter 5, and section 1 is titled Multiplying and Dividing Expressions Involving Exponents. Before we get started, some vocabulary. When you see something like this, 6 raised to the third power, the base is down on the, the line of the paper, and the exponent is the number that's written as a superscript. So base raised to an exponent. So number 1, we're supposed to identify the base and the exponent. The base is going to be 6, and the exponent is going to be the number up above, which is 3. For number 2, identify the base and the exponent. The base is the number that's written in parentheses, so -2 is the base. And again, the exponent is the number that's up above, so the exponent is 3. Number 3, identify the base and the exponent. This is a little tricky. This does not say -9 raised to the 5th. It actually wants you to do a -1 times 9 to the 5th. That's what this means. -1 times 9 to the 5th. So the base would be just 9, and the exponent would be 5. Same idea on number 4. Identify the base and the exponent if you have negative t to the 9th. So that's saying -1 times t to the 9th power. The base will be t, and the exponent will be the power that's above. The exponent is 9. Number 5. What is the exponent for the factor of w in the expression? Wm squared. So when there's not an exponent up there, it's actually understood to be a 1. So the exponent on the w is understood to be a 1. Number 6, write the expression using exponents. I have the quantity of 4t times 4t times 4t times 4t times 4t. So I'm doing 4t, and I want the exponent of to the 5th power. Yes, I'm doing 4t times itself 5 times, so I can write that using exponents as parentheses, 4t, close parentheses, to the 5th power. Number 7, write the expression using exponents. Okay, up at the top, I see x times x times x, so that's going to be x cubed. Don't forget the 7 out front. Over, I see the quantity t minus 3 multiplied by itself how many times? 1, 2, 3, 4 times, so I'm going to raise it to the 4th power. 7x cubed over quantity t minus 3 to the 4th power. Question 8. Evaluate the 2 expressions and compare the answers. Do the expressions have the same value? The first expression is -2 to the 4th. Remember, we've already talked about that negative out front. That's actually -1 times 2 to the 4th, which is -1 times 2 times 2 times 2 times 2. So I'm going to do -1 times 2 is -2, times 2 is -4, times 2 is -8, times 2 is -16. I can also confirm that on my calculator. -2 to the 4th is -16. If I want to do -2 quantity to the 4th, that's -2 times -2 times -2 times -2. This gives me 4 times -2 times -2. This gives me -8 times -2, which would give me 16. So negative 2 quantity to the fourth is positive 16. One thing I want you to notice is the calculator, as long as you enter it in exactly like it looks on the paper, your calculator does the order of operations correctly. Continuing on in part 3, those two expressions, negative 2 to the fourth and negative 2 quantity to the fourth, they do not have the same value. Number 9, evaluate negative 1 to the 62nd power. I'm not going to write that out, but one thing I do want you to watch, if I have negative 1 to an even power, let's say squared, that's negative 1 times negative 1, which is just 1. If I have negative 1 to an odd power, say cubed, negative 1 times negative 1 times negative 1, I would get 1 times negative 1, which is negative 1. Anytime I raise negative 1 to an even power, it's going to be a positive 1. If I raise negative 1 to an odd power, I'm going to get a negative 1. 62 is an even number, so my answer is just 1. If I want to confirm it on my calculator, negative 1 to the 62nd power is 1. Number 10, evaluate the expression. Express your answer as an integer or simplified fraction. Okay, negative 1/2 quantity to the third. So that's negative 1/2 times negative 1/2 times negative 1/2. Negative 1/2 times negative 1/2 is 1/4. Then I still have to multiply by negative 1/2. So I get negative 1/8. Now, if I want to confirm that on the calculator, I'm going to do negative 1/2 to the third power. I get negative 1/8. Evaluate the expression negative 3/4 to the third. So that's negative 1 times 3/4 times 3/4 times 3/4. So negative 1 times 3/4 is negative 3/4. And then I still have two more. So times 3/4, 3/4. Negative 3/4 times 3/4 is negative 9/16. I still have the 3/4. When I multiply those, I get negative 27 over 64. Negative 27 over 64. To confirm it on the calculator, negative, here comes a fraction, 3/4 to the third is negative 27 over 64. Okay, number 12, order of operations. Remember PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. All right, you're going to do the exponent first. So 2 times 0 to the 6th. 0 to the 6th is 0. So 2 times 0 is 0. If you want to use your calculator, 2 times 0 to the 6th is 0. Number 13, simplify. Okay, I've got some exponents going on here. So 5 squared is 25. So 5 squared is 25. Minus 2 times 3 squared is 9, because 3 times 3 is 9. Okay, what was it again? PEMDAS. Okay, next would be multiplication. So 2 times 9 is 18. 25 minus 18 is 7. Now the calculator can do this. 5 squared minus 2 times 3 squared. 5 squared minus 2 times 3 squared is 7. Number 14, expand the following expressions first, then simplify using exponents. So the first part is a squared times a to the fourth. Expanded, there's a squared times a to the fourth. Expanded is that way. In simplified exponential form, that's a times a to the sixth power. Okay, the next one is 3 squared times 3 to the fourth. So 3 squared is 3 times 3. 3 to the fourth, 3 times 3 times 3 times 3. In exponential form, it's 3 to the 1, 2, 3, 4, 5, 6. 3 to the sixth power. Okay, number 15, simplify, write it in the answer in exponent form using the given base. Okay, z times z to the fifth, 1, 2, 3, 4, 5. That would give me z to the 1, 2, 3, 4, 5, 6, z to the sixth. Now, something I want to show you, you have z to the 1 times z to the 5. You get z to the 6, which is 1 plus 5. So when you have like bases and you're multiplying, you add the exponents. Simplify 1 over c times 1 over c squared. Well, 1 over c to the 1 times 1 over c to the 2 is going to be 1 over c to the 1 plus 2, which is 1 over c to the 3. So your answer is 1 over c to the third. Here we go. Simplify c cubed times c to the fourth times c cubed. That's going to be c to the 3 plus 4 plus 3. C to the 7 plus 3 is c to the 10. Now, if you wanted to see all that written out, c cubed times c to the fourth times c cubed, you could count them and there would be 10 c's. Number 18, simplify 7 to the 12th over 7 to the 5th. Okay, I'm going to tell you the rule. A to the m over a to the n is a to the m minus n. When you're dividing like bases, you subtract the exponents. So this would be 7 to the 12 minus 5, which would be 7 to the 7. Now, if you wanted to do it the long way, 7 to the 12 is that over, those are times is all in there, over 7 to the 5th. You could cancel 5 7s on the top and on the bottom. That would leave you with 7 to the 7th power up top. All right, number 19. Up top, w to the 5th times w to the 5th is w to the 5 plus 5 over w squared, which would give me w to the 10 over w squared, which is w to the 10 minus 2, which is w to the 8. Number 20, use the commutative and associative properties. Okay, here we go. 10 times y times 8 times y cubed. That's the same as saying 10 times 8 times y cubed. It doesn't matter what order you multiply things in. Okay, here we go. 10 times 8 is 80. Y to the 1 times y to the third is y to the 1 plus 3. So you have 80 y to the fourth. 80 y to the fourth. 21. 6 times x times q squared times 7 times x squared times q to the fourth. I'm going to multiply the 6 times 7 I'm going to multiply the x times x squared. I'm going to multiply the q squared times q to the 4th. 6 times 7 is 42. I'll have x to the 1 plus 2. And I'll have q to the 2 plus 4. So my answer is 42 x cubed q to the 6. 22. I'm going to write it in a different order. I'm going to say 1/5 times 35 times p squared times p to the 5th times q to the 11th times q to the 7th. 1/5 times 35 is 7. P to the 2nd times p to the 5th is p to the 2 plus 5. Q to the 11th times q to the 7th is q to the 11 plus 7. So my answer would be 7 p to the 7 q to the 18. Number 23. I can do 15 divided by 5. A cubed over a squared. D to the 5th over d, which is actually d to the 1. 15 divided by 5 is 3. A to the 3 over a to the 2 is a to the 3 minus 2. D to the 5 over d to the 1 is d to the 5 minus 1. So my answer is 3, a to the 1, d to the 4, which is written 3a d to the 4. Remember that we don't need to write the 1 as the exponent. Number 24. C to the 12, c to the 4 over c to the 2, c to the 6. Okay, up top, I can write that as c to the 12 plus 4. In the denominator, I can write that as c to the 2 plus 6. So I get c to the, what's 12 plus 4? 16. Over c to the 2 plus 6 is 8. Now I'm dividing like bases, so that's c to the 16 minus 8, which is c to the 8. Number 25. 17 over 8. S to the 4 over s cubed. U, and then t to the 5 over t to the 1. 17 over 8 does not reduce, so we're just going to leave it. S to the 4 over s to the 3 is s to the 4 minus 3. U, and then t to the 5 minus 1. So in the denominator, I just have 8. In the numerator, I have 17 s to the 1, u, t to the 4. I don't need to write that 1 as the exponent on the s, so there's my answer. Number 26, use the formula v equals 4/3 pi r cubed to find the volume of the sphere shown in the figure. Use 3.14 for pi and round to the nearest cubic centimeter. Okay, the radius is 3 centimeters. Let's use this formula. V equals 4/3 pi, and they told us to use 3.14 for pi, and then r cubed. R cubed, the radius is 3 cubed. So I'm going to enter that in on my calculator. Let's see what I get. So here we go, 4/3 as a fraction. I want 4/3 pi, 3.14, and then 3 cubed. I get 113.04. They told me to round it to the nearest cubic centimeter, so the nearest whole centimeter. My answer would be 113 cubic centimeters. All right, simplify the expression. X to the 5b plus 3 times x to the negative 2b plus 5. Those are like bases, and I'm multiplying them. So I'm going to add the exponents. 5b plus 3 plus negative 2b plus 5. So that's the same as x to the 5b plus 3 minus 2b plus 5. So that's x to the, let's do like terms, 5b minus 2b is 3b. And then I have plus 3 plus 5, which is plus 8. My answer is x to the 3b plus 8. Last one, simplify t to the 2a plus 1 over t to the 4a. We are dividing like basis, so we're going to subtract the exponents. T to the 2a plus 1 minus 4a. So that's t to the, combining like terms, 2a minus 4a is negative 2a, and then we still have plus 1. So my answer is t to the negative 2a plus 1.